So today we're looking at 9-3, some more area. These are the last shapes that we are going to be looking at for the unit, and then section 9-4, we're going to be looking at all of the shapes together. So today we're doing area of trapezoids, rhombuses, and kites. So we're going to have to look at what those mean. So a trapezoid is a quadrilateral. Quadra means how many? 4. So that means that it has 4 sides. With a trapezoid, the base, and there's 2 bases, the top and the bottom, they are parallel. So with a trapezoid, the top and the bottom, or the 2 bases, are parallel, but the sides are not. So a quadrilateral, or a rectangle, is a quadrilateral that has 2 parallel bases and 2 parallel sides. A trapezoid, the only thing that it asks for is 2 parallel bases. So we would say that a rectangle is a special case of a trapezoid because it has 2 parallel bases, but the sides are also parallel. Does that make sense? So the trapezoid is kind of like the all-encompassing shape. The height of a trapezoid. So it's very similar to when we're looking at height of a triangle or parallelogram. The height is the perpendicular distance between the bases. So it has to form a right angle. So however long it takes you to get from base 2, which is the bottom, to base 1, which is the top. I suggest that you highlight this or something in your book. The area of a trapezoid is 1/2 times the height times the quantity of base 1 plus base 2. It's actually very similar to a triangle. So when we're looking for the area of a triangle, it's 1/2 times base times height. The only difference is that a trapezoid has 2 bases, so we have to add those together. One thing that you could do, and the way that the formula is actually derived, which I'm not going to do for you, but we could break up this trapezoid into a rectangle and 2 triangles, right? And that's how they get the formula for area of a trapezoid. So they take how you find the area of this triangle, how you find the area of this triangle, add them, and add them to the area of the rectangle. And it comes out to 1/2 times the height times base 1 plus base 2. Okay? So that's one of those formulas that you're going to have to memorize. And then we're just going to do some practice problems. So number 1, what is the area of a trapezoid with height 7 centimeters and bases 12 centimeters and 5 centimeters? So my suggestion is that we draw it first. So I'm going to draw a trapezoid. 2 parallel bases, non-parallel sides. The non-parallel sides are not necessarily the same length. Sometimes they are, sometimes they're not. The height is 7, so I'm going to draw a dotted line to indicate the height, and it's 7 centimeters. One base is 12 centimeters. Oops. And the other base is 15 centimeters. Oops. Okay. So to find the area, first thing I want you to do is always write out the area formula. Area equals 1/2 height times B1 plus B2. And then we plug everything in. Ladies and gentlemen, what is the height? 7 times. Base 1 is usually the shortest one, so what would be base 1? 12. Plus, what would be base 2? The order doesn't really matter. So it doesn't matter which one you plug in for base 1 or base 2. Okay, order of operations say that we do which operation first? parentheses. So in my parentheses, I have 12 plus 15. So this was going to be 1/2 times 7 times 27. Then we do multiplication. And guys, we've talked about this. Does the order in which you multiply matter? No. So I would do 27 times 7 first. Can someone do that for me really quick? 189. And then multiplying by half is the same as dividing by 2. So what is my area? 94.5 what? Perfect. Okay, the other shape that we're going to talk about are kites and rhombuses. Just like a rectangle is a special case of a trapezoid, a rhombus is a special case of a kite. So you guys have all seen kites before in real life, right? Okay. A kite is a quadrilateral, so it has 4 sides. And on a kite, 2 of the sides are congruent, and 2 other sides are also congruent. So it has 2 pairs of congruent sides. Does that make sense? With a rhombus, which is a special case of a kite, all the sides are congruent, but they do not form, or all sides are congruent. Can you think of a special case of a rhombus? So a quadrilateral where all 4 sides are congruent. A square. What's the difference between a square and what's pictured here? A square has all right angles. So a square is a special case of a rhombus. A rhombus is a special case of a kite. Does this make sense? It's kind of like, you guys know how Kleenex is a brand of tissue, and all Kleenex are tissues, but all tissues are not Kleenex? It's the same thing. It's like all squares are rhombuses, but not all rhombuses are squares. And all rhombuses are kites, but not all kites are rhombuses. Okay? So we're talking all these special cases. But the good thing is that no matter what, rhombus or kite, the formula for finding the area is the same because one is just a special case of the other. So the formula for area of a rhombus or a kite is 1/2 times diagonal 1 times diagonal 2. Okay? So they give you the diagonals, and we multiply the diagonals times 1/2. Okay? And it's the same thing. It comes from finding the area of each individual triangle and then adding them together. One thing I want you guys to be aware of is usually when the picture is drawn for you, there's an arrow pointing to the diagonal. Almost always, it means that the whole diagonal length is that number, not just the piece of it where the arrow is pointing. Does that make sense? If it only means half, it will give it to you twice. So sometimes in a problem, I might say that this diagonal is 3, which would make this diagonal 3. Or this piece of it. So the whole diagonal would be what? 6. If it's not given, you can assume that 3 is the length of the whole thing. Okay? So let's do a problem and then we'll do some practice. What is the area of a kite with diagonals that are 12 inches long and 9 inches long? So a kite looks like that second one. So it has 2 congruent pieces and then 2 other, congruent pieces. I think I need to draw mine better. Hold on. And let's draw the diagonals. One diagonal is 12 inches long, so that's going to be the long one. So that's this one. And the other diagonal is 9 inches. So that's that one. Okay. Okay, same thing. I want you guys to write out the area formula. So 1/2 D1, D2. So our area for this one is 1/2. First diagonal is 12. Second diagonal is 9. Did somebody do 12 times 9 for me already? Jen. 108. And what's half of 108, guys? 54 inches squared. How do you guys feel? Okay. So, we're going to do number 3 because it gives us information a little differently, and it's really helpful if you actually draw the picture. So it says that a rhombus has sides 10 centimeters long. So all my sides are the same. So I'm going to draw a rhombus. Okay. Okay.